I built this stock outlook analyzer to analyze stocks from different industries, different market caps and sectors to actually, try to get LLM to see where the stock might go next. You can select these filters or just generate stocks. Then it just finds general stocks such as Apple, Microsoft, Google. Then you get some information about them, such as their market cap, price points, and things like that. And you can actually go ahead and select them up to three. And you can select how much into the future you want to outlook 3 months, 6 months, 1 year, 2 year, and 3 year. Let's go ahead and select 1 year outlook and then click Analyze Stocks, and the analysis process will begin. You can actually see everything happening in the terminal from the FastAPI app. Yeah, this process takes about 10-20 seconds. By the way, we will be reviewing the code, but you can download this from my Patreon. Link will be in the description and in the comments. And when you decide to become a patron, you not only get access to this project, but actually 300 other projects as well. Okay, so we got our stock analysis result. And here's a summary. Here's the price prediction, current price, predicted price, which is expected to go up 4%. By the way, this is not, uh, you know, financial advice. This is powered by LLMs and they can make mistakes. This is for information purposes only. Just keep that in mind. Always do your own research. So here are opportunities and risks. Here is the summary for Visa. Visa is expected to drop apparently, and Netflix is expected to go up about 11%. Yeah, here we go. You can also see the analysis details, which questions were asked to reach this conclusion and their answers. Okay, so essentially we are asking 5 perplexity questions to analyze each stock. You can actually click on show more stocks, and it will actually search and find more stocks automatically. Try to anyway. These stock tickers are coming from Perplexity as well. Select internet services, small cap, and just search. And if you do select something that is unreasonable, such as maybe real estate, which is not related to internet services, and just in case if you don't get any, let's do capital conglomerates. I'm trying to illustrate if you select something that doesn't return any results, then you'll actually get a nice warning message. We haven't gotten it yet, but let's see, health insurance and real estate and small cap. Hopefully, this should return no results. We are still getting some results, but basic materials, maybe transportation and healthcare. Anyway, so if you select, yeah, like this, interesting combination, then you can clear, for example, the sector, and it'll perform an automatic search. So it's really useful. Again, disclaimer is that this tool uses AI models which can make mistakes. Information provided is for research and entertainment purposes only. Keep that in mind, please. Always do your own research. So this is how it works. You can select up to 3 stocks, which it will analyze. And it has some shortcomings, which I will try to update. I'll make a new video when I do. Before we review the code, let's take a look at quickly what's taking place in the background. So once the stock pickers are selected, once the search is performed with your filters, we make a call to Perplexity, allow it to return some tickers, and and then we parse those tickers and we actually compare them against the Yahoo Finance with market cap to ensure that the market cap is actually correct. And for example, in the first call, 10 out of 22 stocks were successfully picked. Then once the stocks are selected, we create analysis questions for each, 5 questions each. You can obviously modify this. And then once we get our answers, all of them are performed in parallel. Then we actually send it again to GPT for a final analysis. And then we do some background processing to actually calculate the percentage change that was predicted. So the downside to all this is that GPT can actually think it's still due to its cutoff date. It's a year and a half earlier than what time it is. So I will try to implement an update for this, but you can also change it as well in the main.py. Now you can download this from Patreon, but now let's begin with the code review. The code will be reviewed by a script that I've written. It's call it the AI Code Explainer. You can also, if you enjoy the explanation that it provides, please do let me know in the comment to see if you rather prefer me reviewing code or the AI. I think AI does a better job than me in a lot of ways. You can also download that code from my Patreon as well. My architect members can download it, and you can find the link to that in the comments and in the description as well. All right, now let's begin by reviewing the code. Thank you.
This part of the code sets up the basic framework and utilities for our stock picker application using FastAPI. We start by importing all the necessary libraries and dependencies, which include FastAPI for building web applications, and other utilities like Jinja2 for templating and Uvicorn for running the app server. We instantiate the FastAPI application with a title and description, setting a friendly tone for our project. Static files for web UI assets are mounted to the /static path, and Jinja2 is initialized to manage HTML templates. Think of this as setting up the welcome sign and putting the right tools in the toolbox before the shop doors open. This setup is essential as it establishes the core infrastructure needed for both the server and the client-side components. This segment focuses on setting up an AI client using Perplexity AI, which will help in fetching stock data by leveraging machine learning models. The API key required to access the Perplexity service is retrieved from the environment variables. We validate the presence of the API key to prevent any access issues, bringing a little AI assurance into the picture, kind of like checking that you actually have your passport before you get to the airport. Additionally, this segment sets up a cache to temporarily store stock data, essentially creating a small memory so we don't have to keep asking our AI friend the same question repeatedly. This caching mechanism is fundamental in optimizing performance and reducing redundant requests to the AI API. This function, Get Stocks from Perplexity, asks Perplexity AI for stock recommendations based on specific filters: industry, sector, and market cap. It's like having a conversation with a search-savvy friend who pulls out stock symbols that fit your criteria. The code builds a query string from user inputs, sends this query to Perplexity AI, and expects a list of stock symbols in return as a JSON array. It handles parsing responses and includes some error-handling logic, a fail-safe mechanism in case our AI pal mumbles and gives us garbled data. This function contributes to our application by acting as a bridge between user inputs and intelligent stock symbol retrieval, ultimately enabling us to populate our application with relevant stock data. This function is all about the art of efficiency, fetching stock information for multiple symbols concurrently using Python's asyncio. It's like having several clones of yourself, all querying different stocks at once to save time and resources. The function defines a nested async function, fetch single stock, which uses the yfinance library to pull detailed data about each stock symbol. By creating tasks for each stock symbol and running them all at once, we manage to fetch data in parallel, making the process quicker and more efficient. The role of this part of the code is to provide detailed stock metadata from Yahoo Finance for symbols retrieved by our Perplexity AI buddy. This data is used to enrich the stock recommendations on our platform, ensuring users have comprehensive information at their fingertips. Here we define two endpoints for our FastAPI application, one to serve the homepage of our web application, and another to handle API requests for fetching stock data. The root endpoint simply serves the homepage using Jinja2 templating. This is the friendly face of our application, the first thing users see when they visit. The /API/stocks endpoint, on the other hand, handles requests for stock data. It takes in optional query parameters like industry, market cap, and sector to filter stocks. This endpoint gets stocks from Perplexity AI, fetches their details in parallel, applies any filters, sorts and formats them, and finally sends back the top 10 suitable stocks to the client. This functionality ties all the pieces of our application together, ensuring users can access stock information that is both relevant and insightful. This segment introduces structured data models using Pydantic, which ensure clean, validated data when working with complex objects like stock analysis results. The stock question model is used for storing questions related to stock analysis, making room for future enhancements such as custom encoders. The stock analysis model is more detailed, encompassing fields like ticker, time frame, price details, and analysis summary. It overrides the dict method to ensure all fields are JSON serializable. Additionally, the segment initializes the OpenAI API client, enabling further interactions with GPT-4, preparing it to provide detailed stock analysis. Overall, these models help manage and sanitize the data we shuttle around, leading to smoother analytic processes and well-structured API responses. This next part of the code uses AI to automate the hard-thinking work, formulating meaningful questions and answers for stock analysis using OpenAI's GPT-4 and Perplexity AI. First, Generate Analysis Questions formulates questions that allow for a comprehensive examination of a stock's potential over a specified time frame. Think of it as asking the right questions to understand the full picture of a stock's history and future prospects. Get Stock Answers interacts with Perplexity AI to find answers to these questions, effectively turning raw financial curiosities into data-driven insights. These functions contribute to our stock analysis toolkit by bridging user-driven inquiries with AI-generated responses, helping us break down complex financial data into digestible insights for our users. This segment revolves around creating a deep and insightful analysis of a stock's prospects using the power of AI. The function Analyze Stock Prospects combines all the previously gathered data, questions, answers, current price, to synthesize a comprehensive stock analysis. The function fetches the current stock price using Y-Finance to ground the analysis in reality. It then feeds questions and answers into GPT-4, simulating a smart financial advisor who provides a structured view of the stock's situation, future potential, and any risks or opportunities it presents. By generating this sophisticated analysis, we equip users with valuable, forward-looking insights about stock market prospects, aligning with our application's core functionality, aiding informed decision-making in the stock market. Here, we define Analysis Request, a Pydantic model to structure requests for stock analysis, accommodating lists of tickers and a time frame. Reinforcing both structure and clarity, this model acts like a security scanner, ensuring only well-formed data proceeds for analysis. The post endpoint, /API Analyze, processes multiple stocks concurrently, leveraging the functions for question generation, answer retrieval, and prospect analysis. Each stock is analyzed in parallel to enhance efficiency, like having multiple screens playing different stock films at once. The endpoint brings it all together, allowing users to submit requests and receive comprehensive stock analyses efficiently, which is the end goal of all our setup, querying, and processing efforts. This is the entry point of the application. It's like the front door where you greet users with a friendly message when they start up the application. This conditional checks if it's the main module being run as opposed to being imported elsewhere, signaling it's time to fire up the app. A reminder message is displayed, reinforcing good practices like graceful exit hints. Uvicorn, a lightning-fast ASGI server, then runs the FastAPI app, bringing our stock-picking brains online and accessible at localhost. This snippet ties up our application, making sure it's up and ready to serve requests, establishing a seamless transition from code organization to full-fledged operation. This HTML segment lays the groundwork for our stock picker's user interface, defining the primary structure of the web page. It follows web standards with elements like doc.html, ensuring our page renders correctly in browsers. The head section links to external style sheets for design flair using Daisy UI integrated with Tailwind CSS, and also imports custom styles. It gives our web application a sleek, modern look with dark-themed visuals, as demonstrated by the data theme and gradient backgrounds. The introductory disclaimer reminds users about the speculative nature of the tool's insights, much like a mindful tap on the shoulder before one enters the thrilling world of stock analysis, reinforcing transparency and user awareness. The neat header displays the application title using attention-grabbing, vibrant styling, setting the scene for an engaging user experience. This snippet focuses on user input options for stock filtering, housed in a visually appealing container. Here, we present a series of drop-down menus designed to let users specify filtering preferences, such as selecting an industry of interest. Enhanced with animations and thoughtful structure through the utility-first CSS framework, Tailwind, the filters container provides inputs for sectors covering various industries, from technology to consumer goods, offering users diverse selection options to personalize their stock analysis adventure. This filtering capability is critical in streamlining the user interaction process, enabling the application to deliver a tailored analysis experience based on specific market interests or constraints expressed by the user. Continuing from the previous input section, this block concludes the filtering options and adds a search button. Users can further narrow their search by specifying a market cap range, from small to large capitalization, enhancing precision in stock selection. The sector selector presents various key sectors, enabling users to constrain results to specific segments of the economy. Following these selectors, the search button kicks off the process, sending users selections for query processing and stock analysis, a tiny action button that bridges intention with action. Collectively, these features empower users to customize how they explore potential stocks, facilitating a more deliberate approach to financial analysis as part of a user-friendly and intuitive interface. As we round out the HTML, it's time for the results section. This part's the stage where selected stocks will eventually appear after the user's input undergoes back-end processing. Initially hidden, stock cards will populate within this section post-query. The script tag at the bottom links to app.js, calling the shots for dynamic interactions, like when the seamless loading spinner takes center stage while data fetches are in progress. These elements aren't just eye candy, they are crucial for delivering end-user satisfaction by gracefully handling transitions between input, processing, and output display, all wrapped up in fluid, modern UI design. This segment of the code serves to initialize the Stock Picker app and set up the groundwork for user interactions. Once the DOM is fully loaded, thanks to the handy DOM Content Loaded event, it readies the essential HTML elements like search button, results container, and loading indicator. It also initializes a set called Seen Stocks, which ensures that previously viewed stocks aren't displayed on repeat. This is like keeping your dating history in the closet when you're back on the scene. Just don't bring it up. The Create Analysis Panel function crafts an adjustable panel at the bottom of the screen, ready to display selected stocks and adjust the analysis timeframe. This panel is crucial because, like an elegant pair of juggling clowns, it holds and manages multiple stock selections seamlessly. Moreover, the code allows for a maximum of 3 stock selections, which is the max stocks variable. With Show Max Stocks warning, it ensures the user knows when they've gone overboard with selections, like a friend stopping you at 3 donuts at the office party. We've all been there. The purpose of Perform Search is to search and fetch stock data based on user input, such as industry, market cap, and sector from a server-side resource. It cleverly handles both new searches as well as refreshing the current set of results without repeating any previously seen stocks. When the function is triggered, it goes into Sherlock Holmes mode, retrieving your selected filters and sending them off to a stock API to bring back relevant data, all while ensuring you're not looking at the same stock result twice. If new stocks are retrieved, they are displayed in a visually appealing manner with animations. It's an async function, a bit like calling room service with specific instructions and waiting for them to bring back exactly what you ordered, or occasionally, just a very empty silver platter if nothing fits your criteria. By keeping loading element visible while the fetching is happening, it sweetly reassures the user that the process is continuing, so don't mash the search button in panic, the stocks are on their way. Here, we've got the code that adds a refresh button and handles the UI when all available stocks for the set filters have been viewed. The Add Refresh Button function adds a neat button at the bottom of the search results, allowing users to refresh and check out additional stocks if there are any more to see. It's like offering an encore in a play, letting users see a bit more if they're really into it. The Show Refresh End State function displays a simple yet stylish message that indicates no more stocks are available to view with the current filters. It's a polite nudge that says, "You've seen it all, folks." The search button calls Perform Search false when clicked, ensuring a fresh start, pun intended, on all searches, prompting new fetch tasks. This ensures users know they've got the freshest, most up-to-date selection of stocks to consider in their portfolio. The Create Stock Card function is the linchpin for visualizing each stock on the page. It creates a card UI element complete with stock details such as symbol, name, market capitalization, price, PE ratio, and dividend yield. In essence, it's the hero card of our digital stock trading card game, where each card can rather nicely fit in your browser. Each card comes with a checkbox that tracks selections. Selecting a stock transforms the card into a visually distinctive selected style, indicating its choice status, a bit like waving a flag during a stock parade. The toggle selection function handles this transformation, ensuring users don't select more than 3 stocks by showing a warning when they try to go overboard. Additionally, cards react to mouse hover, simulating a subtle, "Hey, don't forget me" effect as their visuals shift. It ensures cards are user-friendly and interactive, contributing to a seamless UX, user experience, within the overall aim of dynamically interacting with stock data. The Show Empty State function ensures that when no stocks match the search criteria, a user-friendly message is displayed. This is much better than a blank page, as it provides insight and suggestive actions, gently guiding the user back to viable search options. Moreover, it comes with reset filters, button options, effectively giving users a mulligan to try again with expanded criteria, akin to a consolation cup of coffee. The Show Error State function swings into action when things don't go according to plan during a stock data fetch. We're talking server hiccup sort of scenarios. In such cases, rather than leaving the user with nothing but a spinning wheel of doom and perhaps some mild anxiety, the function provides an informative message about the error. It acknowledges the inconvenience with a touch of empathy and suggests the user try again later. Much like telling a user the elevator is out and to take the stairs, it's not ideal, but at least they know what they're up against. In this portion, the code focuses on handling the stock analysis part of the application, an important function for users to evaluate potential stock investments based on selected criteria. When the Analyze Stocks button is clicked, Analyze Beaten, it gathers the stocks selected by the user and the chosen time frame, preparing them for analysis. Although currently, the actual analysis part is a to-do, a classic placeholder for real work in code reality, the mechanism for handling what happens upon selection is outlined. We also have the Create Analysis Results function, which is designed to display analysis results within a modal overlay. This function formats and presents stock analysis data with relevant sections like summary, price predictions, opportunities, risks, and even some nifty interactive elements to view detailed Q&A about the stock analysis process. A close button ensures users can gracefully exit the analysis screen. An escape hatch for when they realize maybe financial analysis on a Friday night isn't their thing. This code block sets up the process for handling a stock analysis request. It's designed to kick into action when the Analyze Stocks button is clicked, signaling to the application that analysis is a go. Here's the breakdown of its secret sauce. First, it collects the selected stocks and preferred time frame, confirming that data is ready to be served up for analysis. It sends this data to an API endpoint designed to process the analysis /APIs/analyze. Alongside, it provides the user visual feedback via a progress display, making things interactive while the server works its analytical magic. This function is somewhat of a neat freak after itself, ensuring once the analysis is complete, all user-selected stock states are reset and the temporary UI elements like the progress display and analysis panel are graciously removed. If there's an error, it handles it with dignity, displaying an error message and providing a way out for the user via a close button. Consider this a graceful fallback plan to avoid leaving the user hanging in confusion. This part of the code is focused on tracking the progress of stock analysis in a highly visible and interactive manner. The Create Analysis Progress Display function sets up a semi-transparent overlay on the screen with a progress header and space for tracking detailed progress. This ensures users stay informed and engaged while the analysis task is underway, sort of like having a reassuring elevator music playing in the background while you wait. Update Progress for Ticker sequentially updates the progress of each stock's analysis stages, generating questions, fetching answers, and data analysis, using cute little icons and text color changes. It's all about conveying the idea of progress, completion, or any hiccups during analysis in real time. This provides a neat way to visualize and manage where each stock's analysis stands, helping users to have a clear overview of the ongoing background operations. The Create Price Prediction section function creates a visually appealing segment in the analysis results, specifically to display the price prediction for a stock. This piece of code checks if both current and predicted prices are available. If not, it gracefully informs the user that a prediction is unavailable. No smoke and mirrors, just straight-laced honesty. If data is available, a tidy comparison is set up between current and predicted prices. It indicates the potential direction and percentage of price change, complete with color coding, green for up, red for down. Like a financial fortune teller, it helps users get a peek into the future, balancing their excitement or dread with numerical elegance. All in all, this bolsters the analysis component of the Stock Picker app, making it as insightful as it is user-friendly. The code snippet is dedicated to defining various CSS animations and applying them through class selectors. The @keyframes rules specify 3 distinct animations: gradient, changing background positions to create a flowing effect; fade in, transitioning an element from transparent to opaque; and slide up, an element appearing from below and fading in. The corresponding classes, .animate gradient, .animate fade in, and .animate slide up, utilize these animations to add dynamic visual effects to elements. The purpose of these animations is to inject lively and engaging behavior into the UI elements, making interactions feel more natural and visually appealing. Like a magician, it's all about creating an experience that captures the user's attention. Here, we style the stock card elements to enhance their aesthetic and interactive quality. The .stock card class uses gradients, blurring, and transitions to create sleek cards. It sets specs like padding and font size for baseline formatting. The class modifies the card's appearance when hovered or selected, adding interaction feedback, such as elevation, transformed position, and shadow effects. These hover and selection effects engage users, making the UI feel responsive and intuitive. Child elements, h3p.badge, within the cards, get specific styling to maintain consistency across text sizes and spacing. Overall, these styles are about looking professional and keeping those stocks looking sharp. This snippet adds a bit of fun while enhancing interactivity and feedback in our UI components. When a stock card is clicked, the active state scales it slightly smaller to mimic a button press effect, reinforcing tactile response. Then, keeping things energetic,
incorporates
the loading
key
class,
features such as a
likely
theme
used
toggle,
on loading indicators or spinners,
generate
employs the
generate
spin
a
animation to keep
presentation
those
of
viewers entertained, or at least occupied, while content loads. It rotates elements 360 degrees continuously, clearly indicating an active loading state and ensuring users stay in the loop, pun totally intended. Ever seen a button or badge with an ethereal glow? That's the .btn primary and .badge styles working their magic. They add a glow effect via box shadow that visually lifts these elements off the page, giving buttons and badges some star quality. This subtly enhances visual hierarchy, drawing attention to key actions or important statuses, thus improving usability gently by guiding the user's eyes right where they need to go without shouting, "Hey, click me." These styles focus on layout consistency and responsiveness. The .container class ensures the app's content doesn't stretch beyond 1400 px wide, letting us breathe easily without excessive scrolling. Then, @media queries create adaptive padding adjustments for different screen widths, making sure content looks organized whether viewed on a tablet or a widescreen. It's like yoga for your UI, dynamically shifting to achieve perfect balance. This adaptability ensures content stays accessible and visually pleasing across all devices. This segment involves animations for transitions of a stock pill, presumably some UI component that appears and disappears dynamically. It defines entry and exit transitions using the combination of opacity and scaling effects. For example, when stock pill enters, it grows into place while fading in, making these transitions feel smooth and seamless. Withdrawal does the opposite, creating a cohesive experience that strengthens the interface's sophistication. They elegantly appear and withdraw like fine performers exiting a stage. This style snippet deals specifically with the hashed analysis panel. Its box shadow adds depth, ensuring this panel visually sits above other content, enhanced further by the z-index level. This setting helps manage layering, so your important analysis doesn't get buried like treasure on a deserted island. It's all about getting those key insights front and center without interruption. Last but not least, this snippet addresses animated transitions for warning messages. Warning enter and warning exit classes cleverly manage transitions with the appearance or departure animations describing entry from the side and fading, creating a more dynamic and less jarring notification method. These transitions ensure warnings capture attention without overwhelming, balancing functionality with user experience harmony. It's sort of like a friend waving subtly to let you know they've got something important to tell you. Not overwhelming, but enough to draw your gaze.
I would like to take a moment to talk about the benefits of becoming a patron. As some of you may know, in the last year and a half, I've spent 3,000 hours, over 300 projects as a patron. You will have access to all the code files so you can get inspiration and iterate quickly. Another benefit is that you'll have access to all my courses. And my most recent and most proud one, the 1000x Masterclass, teaching what I've learned on how to code fast and efficiently. Also the Streamlit course and the FastAPI course. In my Patreon, I also have tiers in which you can connect with me one-on-one. Check those out as well.
Now, listen to me. I've been trying to code, and I like coding. The fact that I can code and make things happen, but how do I do it? I mean, fast with AI. I'd heard about it. It's easy. So, I came across 1000x cursor course. And that's great, it just made everything super silky smooth. It just worked. I'm telling you.
1000x your coding.